Yes, friends, here this is question number 14.23 of NCERT book from class 11. Circular disc of mass 10 kg suspended by wire attached to center. The wire is twisted by rotating the disc and released. The period of the period of torsional oscillation is found to be 1.5 seconds. The radius is 15 centimeters. Determine the torsional string constant. पूछा गया torsional. Determine the torsional string constant. I told you while teaching this when we rotate the disc gently and release it, it oscillates to and fro. So that time period was given by t equal to 2 pi under root I upon c. Here c is equal to torsional constant. c equal to दो नाम इसके रेस्टोरिंग टॉर्क है, रेस्टोरिंग टॉर्क per unit angle of twist or also called as torsional constant भी कहते हैं. तो C निकालना है. T 1.5 second 2 pi under root I. I equal to mr square by 2. Sorry, moment of inertia of disk about the axis. Yes, it is disk. Mr square by 2. Mr square upon 2 into C. T equal to 1.5 second, radius 15 centimeter. So how to solve this? 2 pi under root m 10 kg r 1.15 square upon 2 into C 1.5. Now 0.15 square may be taken outside. 1.5 is equal to 2 pi into 0.15 under root 10 upon 2c. Or simply you can solve it this divided by this. 10 is equal to 2 pi under root 10 upon 2c. If we square both the sides, so 100 is equal to 4 pi square into 10 upon 2c. Or C equal to 2 pi square into 10 upon 100. This is 10 pi square nearly pi square 3.14 square. Listen dear friend, remember pi square nearly it comes out 10, actually 3.16 होता है exactly. तो here this C comes out to be 2 Newton meter per radian. Actually such type of question generally asked in competitive exam So this is not, we can't say this is beyond syllabus. Actually, our syllabus is simple harmonic motion. Any motion which can be simple harmonic cannot be called out of syllabus. Teachers in the name of syllabus keep on avoiding the situations. We have to think each and every situation. I hope you have got my point. Now there is another question from NCERT book again. Last question है 14.24. 14.24. ये सिंपल क्वेश्चन है वैसे, लेकिन जब करना होता है तो गलतियां होती हैं. A body describes simple harmonic motion of amplitude A 5 centimeter and period T 0.2 seconds. Find the acceleration. Find acceleration and velocity. Find acceleration and velocity at displacement x equal to 5 centimeter. B1 A part, B part at 3 centimeter and C part at 0 centimeter. तो हाउ टू फाइंड एक्सेलेरेशन. जब हम रिकॉर्ड करते हैं तो हम नाम भूल जाया करते हैं. इन SHM अल्फा इक्वल टू ओमेगा स्क्वायर वाई माइनस साइन तो टेल यू डायरेक्शन ऑलवेज टुवर्ड सेंटर होता है. तो यू आर आस्क्ड एक्सेलेरेशन एंड वेलोसिटी ओमेगा अंडर रूट ए स्क्वायर माइनस एक्स स्क्वायर या वाई स्क्वायर जो लिखे हैं, एक्स लिख लीजिए यहाँ क्योंकि हमने एक्स लिखा है. तो अल्फा नंबर ए पार्ट अल्फा 5 सेंटीमीटर है भाई इक्वल टू ओमेगा 0.2 स्क्वायर इंटू 5 सेंटीमीटर 0.04 इंटू 5 यानी कि 0.2 सेंटीमीटर पर सेकेंड स्क्वायर. वेलोसिटी ओमेगा अगेन 0.2 अंडर रूट ए 5 सेंटीमीटर 25 minus 25 0. You know at extreme position velocity 0. B part at x equal to 3 alpha equal to omega square तो 0.04 into 3 0.12 सेंटीमीटर पर सेकेंड स्क्वायर. सॉरी यहाँ छूट गया. B here equal to 0.2 into 25 minus 9 that is 16.4. So it is 0.2 into 4 0.8 centimeter per second. At x equal to 0 alpha 0 at C part at alpha equal to 0 but v equal to maximum होगा v equal to 0.2 into 25 का अंडर रूट 5 25 minus 0 अंडर रूट तो इट इज 5 0.1 सॉरी 5 to 10 1.0 सेंटीमीटर पर सेकेंड. तो जब करना होता है तो हमें वी फील समहाउ डिफिकल्ट, तो इसलिए हमें क्वेश्चन प्रूव करनी है. वी मस्ट सॉल्व बाय आवर पेन, बाय आवर ब्रेन, बाय आवर हैंड. समटाइम ब्रेन एंड हैंड्स डू नॉट वर्क टुगेदर. Mind saying write 10, we write 20. So this happens. These mistakes can be known by doing the things. Learning by doing is the best method. Learning by listening is also one thing, but learning by doing Actually, I don't know how many times I have done these questions, but when we do, we can commit mistake. Now, there is a very good question, 14.25. 14.25. Mass attached to spring, free to oscillate with angular velocity omega on horizontal plane without any damping or friction. Here a mass m is stretched. Place here, it can oscillate here to and fro. It is pulled to distance x0 and released and pushed with velocity v0. By mass is pulled by distance x0 and then given a push with velocity v0 towards equilibrium position. To determine the amplitude angular frequency is omega. This is x0. Omega the angular frequency. So you are asked here, determine the amplitude of the resulting oscillation in terms of omega, x0 and v0. देखने में सवाल लगता है कि ये हम क्या हो रहा है, तो ठीक है, it appears that x0 the amplitude, no, it has been given push with velocity v0, so this is not equilibrium position, extreme position. So we know if I take x equal to a cos omega t plus phi. Suppose I take this equation of SHM, or you can take y equal to, but that is not matter. आप ऐसे ले सकते y equal to a sin omega t plus phi. Here phi equal initial phase. If I take this is x, then velocity v will be minus a omega sin omega t plus phi. यहाँ पे क्या होगी v? यहाँ v बराबर हो जाएगा a ओमेगा cos ओमेगा t प्लस फाई. अब वो कह रहा है कि at t equal to 0, x equal to x0 and v equal to v0. Whether you use this equation 1 or 2 or use this thing, you will get same thing. So putting x equal to x0 at t equal to 0 here, x0 is equal to a cos phi. Putting t equal to 0 here, v0 is equal to minus a omega sin phi. Now here v0 upon omega equal to a sin phi. Take this equation 4. Because we want to square and add both sides to know a square. Adding and squaring both sides of equation 3 and 4 and adding them, we get x square plus v0 square upon omega square equal to a square or cos square phi plus sin square phi. You know this is 1. So a square equal to x0 square plus v0 square upon omega square, or a equal to under root x0 square plus v0 square upon omega square. Dear student, these questions are meant for students to do themselves. I know this thing. But we are making it simple for you so you practice yourself. Try to solve the question yourself. It is in your interest. It will increase the learning. Apply brain again. Once you have seen the solution, don't see again and try to get the solution yourself. That will help you. You might be thinking about my cap because here I have to remain inside room, so I feel something cold. Don't go on this. Now I have left one question of NCERT book. I will finish that also. I told, okay, we have derived the equation by taking a reference circle like this. Okay, body was moving like this, and here it is this y upon a sin theta या इनिशियल फेज फाइनल. तो उसी को रिपीट करा रहे हैं आपसे. ये कह रहे हैं फॉर प्लॉट कोरोस्पोंडिंग रेफरेंस सर्किल. It is question number 14.12. Plot corresponding reference circle for each of the following simple harmonic motions. Indicate the initial t equal to 0 position circle, the radius circle, angular speed of rotating particle. For simplicity, the sense of rotation may be fixed to be anticlockwise in every case. X is in centi second. Now time t is in second. So here a part is here given x equal to minus 2 sine. X equal to sine 3t plus pi by 3. This is one. B part is given x equal to cos 6 pi upon 6 minus t. C part is x equal to 3 sine 2 pi t plus pi by 4. And then D part is there, x equal to 2 cos pi t. So you have to tell reference circle of these motions as x projection. When I told you that simple arm motion is the projection of uniform circular motion on any diameter. That is simple case. So here I take a part, x equal to minus 2 sine 3t plus pi by 3. You know, cos 90 plus theta. Cos 90 plus theta means cos pi by 2 plus theta is minus sin theta. So I can write this as x equal to 2 cos 3t plus pi by 3 plus pi by 2. By whether you write theta plus pi by 2 or pi by 2 plus theta, the same thing. So it comes out to be x equal to 2 cos 3t plus, if we add this, we get 5 pi by 6. Addition of these two give. So you are asked at t equal to 0, at t equal to, we have to at t equal to 0, we get initial phase phi equal to 5 pi by 6. It means 5 into 30, 150. A is 2 centimeter, omega is 3. तो सर्किल का बनेगा रेडियस दिस आर इक्वल टू 3 सेंटीमीटर, नहीं सॉरी 2 सेंटीमीटर, and initial phase t equal to 0. It is here 150 degree angle total. अभी इनिशियली p जो है at t equal to 0 here, at t equal to point p here, omega 3 रेडियन पर सेकेंड, ओमेगा 3 रेडियन पर सेकेंड. आई होप यू आर गेटिंग माई पॉइंट. एक्चुअली अगर हम सोचते हैं यहाँ पर क्या कोस 90 प्लस थीटा था ना, या थीटा प्लस 5/2, तो हमारा ये जो था ये थीटा है प्लस ये 5/2, तो यहां से मैं 90 घुमाया t इक्वल टू 0 पर, तो ये क्वेश्चन हो गया. ठीक है. अब जो हमारा सेकंड पार्ट है भाई, बी पार्ट, x इक्वल टू कोस pi/6 minus t. You know cos minus theta is equal to cos theta. So this equation cannot be written as or x equal to cos t minus pi/6. It is initial phase 30 degree minus a equal to 1 centimeter. तो आपका सर्किल हो गया ये रेफरेंस सर्किल. दिस इज आवर रेफरेंस सर्किल हियर. भाई यार ये चौक है. तो एट t इक्वल टू 0 इट इज हियर एट p at t equal to 0, rotation like this, initial phase pi/6, radius 1 centimeter, omega 1 रेडियन पर सेकेंड. कहाँ से आ? इफ वी कंपेयर इक्वल टू कोस ए कोस ओमेगा टी प्लस 5, ओमेगा इज 1, ए इज 1. दिस इज पार्ट बी. नाउ कम टू पार्ट सी. अगेन सी देयर x इक्वल टू 3 sin. Dear student, please make your mathematics strong. Bio student has to learn this much thing. Trigonometry class 10 में पढ़ाई जाती है ज़्यादातर. When we were in class 10 we were told all things, but nowadays the standard has been lower in class 10. I don't understand why. हमने ना x projection, तो we have to convert it cos 90 minus theta is called sin theta. So here we can write it as x equal to 3 cos 2 pi t plus pi/4 minus pi/2. क्योंकि cos 90 minus theta या 90 plus theta वो the same thing. So it comes out to be 3 cos 2 pi t minus pi/4. This difference will come out pi/4. घटा लीजिएगा, नहीं है किनारा. pi/4 minus pi/2, LCM 4, pi minus 2 pi, तो minus pi/4. तो at t equal to 0, phi equal to minus pi by 4 means 45. Radius 3 centimeter, omega 2 pi. So circle, reference circle will be like this. Pi by 4. P at t equal to 0 here. Omega 2 pi. Radius 3 centimeter. Motion this way, pi by 4. So this is reference circle here. X, ये भी ध्यान रखना x y dash, because you have to show x projection. और 25 सेकंड. Now last is simple. Initial phase 0, D part. So it is here. X projection. T equal to 0, cos 0, 1. तो 2. कहाँ मिलेगा? Here. P at t equal to 0. हाँ भाई, t equal to 0. Motion like this. A 2 centimeter, omega pi. Here omega pi. और A radius 2 centimeter. थोड़ा वीडियो लेंदी हो गया, सॉरी, मैं ध्यान नहीं दिया, बट मैनी क्वेश्चन हैव बीन सॉल्व्ड. प्लीज वॉच दिस वीडियो केयरफुली एंड like if you feel good solution and good questions, then like it.